The first part of Unit 6 deals with circular motion. And first, we're going to talk about frequency, period, and velocity. So, what is frequency? Frequency is how many cycles there are per second measured in inverse seconds. So, if something goes around, 5 times in 1 second, so pretty fast, the frequency will be 5 inverse seconds. Now, the period is the inverse of frequency, so that's the time needed to complete one cycle. So if a ball, let's say spinning on a string, goes around 5 times in 1 second, it actually takes a fifth of a second to make one complete cycle, and period, because it's a unit of time, is measured in seconds. So we see two equations. Frequency is 1 over period, capital T, and period is 1 over frequency, as they are inverses of each other. We take a look at an example of this. A wiffle ball on the end of a string is twirled around, making 20 revolutions in 15 seconds. What is the frequency? Well, frequency is 1 over period, but we don't necessarily know the period yet. We just know it goes around 20 times in 15 seconds. So the frequency would be 20 revolutions over how long it took, 15 seconds, giving us 1.33 revolutions per second, or inverse seconds, s to the -1. Now, what is the period of revolution? In other words, the time it takes to make one complete cycle instead of 20, well, that's going to be 1 over our frequency, 1.33. We get 0.75 seconds. Or we could have actually just done the inverse of what we did in part A. We could have done 15 seconds divided by 20 revolutions and got the same answer. In terms of velocity and circular motion, velocity is often referred to as tangential velocity, or how fast the object is moving perpendicularly to the radius. So that's what tangential means, perpendicular. So if we look at the picture to the right, if we have a ball on the end of a string moving in a clockwise fashion in a circle, at the point all the way on the left, at that instant, the instantaneous, we would call it velocity, or in this case the tangential velocity, is pointed straight up. And as it moves around, it constantly changes direction. In linear motion, we know that speed equals distance over time. So in circular motion, velocity, or the tangential velocity, is 2 pi r over period. That 2 pi r comes from the equation of a circumference of a circle. 2 pi r, that's the distance it takes to go around one time, and then the period is how long it takes to go around one time. So we look at an example. A ball is attached to a string, makes 2 revolutions every second. The length of the string is 0.8 meters. What is the velocity of the ball? Well, we know velocity is 2 pi r over period, but we first need to figure out what the period is. We know that the frequency is 2 revolutions per second, or 2 inverse seconds, and we know period is 1 over frequency, so basically half of a second. So to figure out the velocity, 2 pi radius of the circle, so that's going to represent the total distance the ball travels in one revolution, divided by the period. How long does it take to make one complete revolution? So we get a tangential velocity of 10.1 meters per second. If a ball on a string is being twirled around at a constant speed, is it accelerating? Now, constant speed, we might think, well, no, because acceleration is a change in speed, but it's actually not. Acceleration is a change in velocity, and velocity is a vector, meaning it has a direction. Because when a ball goes around in a circle, every instant as it goes around the circle, its direction is constantly changing, as we saw in the previous page, the notes, the little diagram. Because of that change in direction of the velocity, that means that there is an acceleration. So anything moving in a circle is constantly accelerating. Now, in order for any object to move in circular motion, there must be an inward pushing force that keeps it moving in that fashion. And this is called a centripetal force. If there is a net force on an object, it is said to be accelerating. So we already know that F equals ma. The acceleration, centripetal acceleration equation is v squared divided by r. So because F equals ma, we can essentially say that the centripetal force is equal to mass times velocity squared over radius. Now we make a note that a centripetal force is a general type of force, and this can be a variety of forces. So a centripetal force can be friction, it can be tension, it could be a normal force, depending on the situation. So in this particular activity, we have 4 different situations, and we decide what kind of force a centripetal force is. Now notice that all of these situations deal with an object moving in some sort of circular fashion. So for example, the first one, a car makes a right-hand turn. Well, if a car is turning, if it keeps turning, if the steering wheel stays fixed as it's turning, it's going to continue making a right-hand turn. Now, the only way it's able to make that turn is because there is friction between the tires in the road, and that friction between the tires in the road is what allows the car to move in a circle. So friction in that case would be the centripetal force. For number 2, close spin inside the walls of a washing machine. That would be a normal force, because if you've ever seen this happen, you see that after you pull the clothes out or before you're about to pull the clothes out, all the clothes are on the edge or the outside of the machine. This is because they're being there's the inertia is keeping them to the outside, but it's that centripetal force that keeps it literally inside of the dryer. Number 3, Earth orbits around the sun. That's gravitation, which we'll get into in the next notes. And number 4, ball twirled on the end of a rope. Well, the ball goes in a circle because it's connected to a rope, and there's tension in this rope. If you let go of the rope, the ball is not going to continue moving in a circle. It's going to fly off on a tangent. So we see an example of a 1,500 kilogram pickup truck attempting to make a turn of radius 12 meters at a speed of 9 meters per second. So what is the centripetal force on the truck? Well, centripetal force is mv squared over r. So mass 1,500 times velocity squared, 9 squared over 12, is 10,125 newtons. Now part B, what is the minimum coefficient of friction between the tires and the road such that the truck does not slip? This is a good example of where our centripetal force is our frictional force. The only way this happens is if that centripetal force is equal to the force of friction between the tires and the road. So we set our centripetal force equal to mu mg, and that mu mg comes from our friction equation, mu times the normal force, which in this case is just the force of gravity, m times g. So we see that the mass cancels out anyways, but when we ultimately end up solving for mu, we see that it is 0.689. The last part of these notes deal with centripetal versus centrifugal forces. So what's the difference between the two? Centripetal force is center-seeking. That's what centripetal means, and it's a real force, and we'll talk about what that means. Centrifugal, on the other hand, is center-fleeing, and it's a fictitious force, so it's not an actual force that is acting on something. So think about this situation. When you make a left-hand turn in a car, which way does your body go? And why is that? So imagine yourself driving down the street, you're taking a left-hand turn, your body's going to go to the right. Now the reason for this is not because there is some sort of mysterious force pushing you, it's simply inertia. Your body wants to keep going straight, but relative to the car, it feels like your body is going to the right. Now the reason why you're able to move in a circle with the car is because there's other forces acting on you, i.e. centripetal forces, such as maybe the force of friction between your chair and your butt, or any other forces, maybe the center console, normal forces pushing you inwards, whatever the case is, but it's keeping you inside of the car, but you feel like you want to go to the right because of inertia, and that's really that centrifugal force. Not a real force, it's simply just inertia.